All right, dude, we are live. What's up, guys? This is Dem Keys, and today we are going to continue learning about doing ESP32 programming in Rust. Since yesterday's stream, I've been doing a bit of research and I've been trying to understand. I actually got a little sidetracked as well with some other research. Um, Something audio related, something well, audio related, but still related to the ESP32. That's separate research. For now, I'm trying to understand um, this folder structure. Hold on, let me show you guys. Where am I? Here. So this is a Rust project that I made using ESP Generate, and in this project, give me a second. Yeah, in this project, I noticed something in the source folder. Usually, if you make a Rust project, just the regular cargo init method or cargo new method, it'll create this kind of folder structure, but it'll also have a main.rs file, and usually it's just that. It doesn't there's no like extra directories, at least with the default behavior. And it's also a similar thing for libraries, I believe. Like if you're trying to create a library kind of project and not a binary project, then you're going to have a lib.rs instead of main.rs. But I've never seen bin. Actually, I haven't worked too much with library type of projects, as in, building a library project. So I can't say for sure if this bin folder would be present there. But the point is, I'd never seen this kind of structure before, where the source file has a bin for the source directory has a bin directory, and in the bin directory you have a main function. So that was kind of confusing to me. So I was doing some research on that, and it turns out that this is a concept of um, or this falls under the concept of cargo targets, which, from what I understand, are different from compilation targets of the Rust compiler. Um, in this case, the type of target that you have, it it determines the kind of behavior that cargo is gonna have towards whatever you're pointing it towards. So some examples of targets are your regular, main.rs, then your examples folder. In this case, you have this bin folder, right? I also found out that you can have multiple folders like this bin folder. Um, are you guys able to see? Yeah, okay. Um, you can have multiple directories similar to this, and then uh, when you're typing cargo run, I believe you can do something like this. You can give a bin flag and then give the name of the binary that you're trying to run, and then it's going to look for a directory with that name and run main.rs in that. And this was new information for me because I didn't know you could do this. I knew that there's an examples thing, which is why you are also able to do examples and then give a name of one of the directories uh, that's in there, and then you'll be able to run this example. And I was doing research on this through another tutorial that I was doing, which was I think workspaces. Yeah, it was a concept of workspaces in Cargo, where you could set up one sort of parent project, and then all the other, you can have multiple other projects within it that are essentially child projects, but they all fall under this one project. And there are certain situations where you would need to do that kind of thing. Um, so that's why I was kind of exploring that concept. I never actually finished that tutorial, so I didn't get too far with learning about workspaces. And that reminds me, I should do that. I should, you know, go forward with that. Um, but yeah, I was doing this research, and I'm gonna read out what I was having a conversation with Gemini about this, and I'm gonna read the last part of the conversation, or the latest part of the conversation. So I was like, okay, hold up, let's keep ESP aside for a second. I looked into this source slash bin directory structure, and it turns out that it's a way of specifying something called cargo targets. I'm gonna need you to give me a rundown of each of these targets, what they are, how they're used, and how this concept of sorry, how this concept of targets differs from compiler targets such as x64 or RISC-V, Extensa, etc. Give me a second. Let me drink some water. Okay. Give me a second. I just remembered that I have to open up my stream on my phone so I can see the chat. Okay. All right. Okay. Cool. So, yeah, the response from Gemini was in the Rust world, the term target is unfortunately used for two very different things, which is exactly why it's confusing. To clarify, let's look at cargo targets, which is the project structure, versus compilation targets, which is the hardware. Okay, cargo targets. Cargo targets are basically the what are we building. A cargo target is a unit of compilation. When you look at your source folder, Cargo sees Cargo sees files and infers what kind of artifact it should create from them. So for a library, the purpose is reusable code used by other targets. It doesn't run on its own. So to run it, it has to be linked into others. Then we have binary, which is through source slash main or source slash bin slash. Oh, that's interesting. So here it says asterisk dot rs. It doesn't say main dot rs. So that means I guess the name can be anything. Okay. Executable program. Oh, wait, was I wrong to say earlier that you can have multiple directory? No, I read that in Cargo, in Cargo's documentation, that you can have multiple directories um, with different names, and then you can use those names. Okay, I'm gonna need to test this out myself. We can do this. We can test this out. Um, yeah, we can test this out today, I guess. Okay, so that's binary. That's executable programs. Each file in the source slash bin becomes its own standalone app. I didn't even know that was possible. And to run it, you use cargo run and then the bin flag and then the name of the binary. Then you have examples, which is under the examples directory. Um, this is demo code for users. These are binaries, but only built when requested. To build them, you use cargo example. Then you have tests, which is integration tests that test your library from the outside. Then you have benchmark, which is performance testing code. You use cargo bench for that. Now, in your ESP32 project, because you have source/lib and source/bin/main, Cargo is actually building two things. It builds a library, which is your logic, and then it builds a binary, which is the actual app that imports and uses that library. Compilation targets, the where it is running. This is what people usually mean when they say target triple. It describes the CPU architecture and operating system the code is being built for. Some examples are x86 underscore 64 unknown Linux GNU. So it's giving examples of different targets where you'll have like I forgot what it was. It was architecture, and then something, and then OS, and then something more. There was a specific format for it. So in this case, you have architecture like x86 underscore 64, then unknown. I forgot what the second thing was supposed to be. Then you have OS if it's applicable. In the case of Extensa, we usually do, in the case of Extensa no STD, we usually do none because it's running on bare metal. And then you have the fourth one is supposed to be a format, I guess. There's a specific name that they're given. I don't know. I don't remember what the name was, but there's a name that they're given. In the case of Linux, it would be GNU. In the case of ESP32, it could be ELF or anything else. So how is it used? To specify, no, you specify this via the target flag in the terminal or in the cargo terminal file. The difference between project target versus hardware. Okay, I've gotten that. That's okay. How they interact in your workflow. When you run a command, you are often picking both. Yeah, see, this is interesting. I've never actually done this, and this kind of opens up some doors for me because I've never actually thought about being able to have multiple individually executable, let's say main files, because usually it's just main.rs, right? I've never thought about being able to execute something else. Let's hold on. Let's create a test Rust project. So let's say cargo. Actually, wait, let's create a. Oh, didn't mean to do that. Let's create a new directory. Let's say some Rust proj 01. In here, let's do cargo init. Oh, so my next question should be, okay, so how do I create a project where there's src/bin/ so and so .rs structure? Or is it something I must do manually? Also, I remember reading somewhere, give me a second, this thing is kind of blocking my ability to type. I remember reading somewhere that in the bin folder, you can have more folders, and then each of those folders can have a main file, and then each of those folders names would be treated as a separate binary. Is that a thing? Or did I misunderstand what I was reading? So while this is happening, Here, let's create a new thing. Yeah, let's copy. Don't delete that. Let's copy and paste. And just a second. Um, just okay. Let's open up the project here, and over here we can start doing the extra stuff. Oh, okay. Yeah, here's so I got the response from Gemini. It says, you've got it exactly right. It is absolutely a thing. What you're describing is how Cargo handles implicit binaries. You don't need a special command to create the structure. Cargo automatically recognizes it as long as the folders and files are in the right place. How to create so and so structure. When you run Cargo new project, it gives you a flat structure with with just a main.rs. To get the structure you're seeing in your ESP project, you just do it manually. You create a directory, so and so, so and so. Okay, okay. Once files are in source/bin, Cargo stops looking for source/main and starts treating every file in that folder as a separate binary. Then the nested folder structure, multi-file binaries. I was talking about multi-folder. What was I? Yeah, yeah. I was talking about like multi-folder, as in one binary in each folder, or one binary being made for each folder. You remembered correctly. If a binary gets too complex for a single file, you can give it its own folder inside so and so. The rules. Oh, okay, okay. The rules. If you have source/bin/my_app.rs, the binary name is my app. If you have source/bin/my_app/main .rs, the binary name is also my app. This allows you to organize a specific binary into multiple submodules, like so and so, so and so, so and so, okay, while keeping it separate from the others. Example project layout. Okay, let's try. Oh, wait, I have one more thing. Okay, so how does or how are project dependencies handled in this case? And when it comes to IntelliSense, bracket, I'm using NeoVim with LazyVim. When it comes to IntelliSense, will I have issues due to there being multiple, what do you call it? Due to there being multiple, yeah, multiple binaries. Now, while that is, while words, while I get the answer for that, let's set up the folder structure here. Let's do, let's say app01, and yeah, let's create two, well, two more. So app01, O2, and O3, and in here we'll have a main.rs. We can yank this as well. Don't paste it here. Um, paste, paste. Okay. So we have multiple things here. Okay. Um, right. So let's open this up and open this up. So I'm glad that NeoVim is showing it's showing the sort of breadcrumb. Okay, this file is not included in any crates, so Rust Analyzer can't offer. Oh, okay. We seem to have an issue with this specific file. If you're intentionally working on unowned files, you can silence this warning by adding unlinked file. Why is that? And why is it specifically for app O3? Why not for the others? Let's see if IntelliSense works. So let's say use, okay, nope, IntelliSense doesn't work. What about here? Yep, doesn't work here either. We have an issue. IntelliSense works here. So I can do std IO. I'm not going to be using that, but yeah, I can do that. This file is not included in any crates, so the Rust analyzer can't. Okay, so we've just run into an issue. Okay, Gemini gave the response. So when you have multiple binaries in one project, dependencies and editor behavior change slightly compared to a single file script. How dependencies are handled. In a standard cargo project, one cargo toml, dependencies are global for all targets in that package. Shared pool, if you add CRD to your dependencies, both librs and every file in bin can use it. Compilation, cargo is smart. If binrs uses a heavy library like Tokio, but if bin A uses a heavy library like Tokio, but bin B does not, bin B will not include Tokio in its final compiled size. However, both will be rechecked by the compiler if the dependency changes. Linking to lib, every binary in bin automatically treats source lib as an external crate. If your project name in cargo toml is so and so, you access your library code like this. Okay, NeoVim. Using lazy Vim is actually a big advantage here because it typically uses Rustation Vim, which is the gold standard for Rust and NeoVim. Generally, the Rust Analyzer, which is the engine behind the IntelliSense, handles multiple binaries perfectly fine, but there are two gotchas to watch out for. The check all delay. No, actually, in this case, it doesn't seem to be handling it. Um, okay, let's try something here. Okay, let's quit this and try to relaunch it. See if it works now. Use, nope. Okay, so here it's talking about the delay, the check all delay, and then the target conflict. Since you are doing ESP32 work, your code likely won't compile on your host. Your code likely won't compile on your host. If your Rust analyzer tries to check your code using the computer's default settings, you'll see a sea of red errors, as in cannot find ESP HAL. Yeah, I think for that purpose, just a second. Let's open a new tab here so we can go here. For that purpose, I think we have a couple of things. We have the Rust toolchain, but we also have this. Oh, wait a minute. Channel ESP. So I think this tells what do you call it? This tells Cargo which specific toolchain to use, because I have, where do I do it? Here, Cargo, no, Rust up toolchain list. So I have 3 toolchains installed here. One of them is for ESP. So I think this is what tells it which toolchain it's supposed to use. But yeah, okay. Here, I believe in config, somewhere it mentions something that gives the Rust analyzer an idea. So I think we should be good on that front. Okay, let me type out this. Okay, so I created a new a new Rust project using Cargo in it. Here there's no ESP32 involved. Inside the source directory, I created 3 directories, app01, app02, and app03. In each of them, I created a main.rs file. I then opened all 3 of the main files. There's also a main file in src itself. Here's my issue. Each of the main files in app01, app02, and app03 seem to be giving a warning from, I think it's from the Rust analyzer. Hold on, let me. Okay, it's just saying diagnostics. From diagnostics, saying maybe I could just copy this entire thing. Is it going to copy? Yeah, it copied. Okay. Let's see. Okay, the classic implicit discovery trap words. The classic implicit discovery trap. You have the right idea, but you are missing one specific directory level required by Cargo's conventions. In Rust, Cargo doesn't just look for any folder with a main.rs. It's specific. Oh shit, I forgot about bin. I forgot about bin. That's crazy. Okay, wait, I completely forgot about bin, dude. That's crazy. Wait, what's going on here? Okay, so I'm gonna need to move these, which means I need to close each of these. Yeah, yeah. Might as well close NeoVim at this point. So let's go back into Yahtzee. And here I need to create a bin folder. And then XXX, wait, X. How do you... Oh, let me select all of them. There. Okay, done. Now let's open it up and Well, yeah, reloading the session doesn't make any sense. Okay, cool. I've got the same structure now. Great. So let's see. Main function not found. Okay, cool. So we just create a main function. Wrong thing. Actually, IntelliSense will have a thing for me, right? Yeah, there we go. Here I just want print line. App01 binary. All right. Let's copy. Hold on. I don't know. I don't know why that happened. Wait. FN main. Okay. Undo. FN. What if I just type main? Oh, okay. This is how you do it. I was wondering why I wasn't getting that completion thing. In this case, I had to type main, so then it would complete the entire thing for me. But yeah, okay. Paste, save this, and let's open up the others. Okay, paste. The only thing I need to change here is this, and then paste and change this. Okay, now we should be able to do stuff here. Let's say, I don't know, sum A I32, B I32. This returns an I32 as well. And here we just do A plus B. So if IntelliSense is working, we should be able to do let A equals sum 5 and 10. Cool. Awesome. So now we need another place to run this. Actually, we don't need another place. We can just do it here. Cargo run bin app01. Done. App02, app03. Hell yeah, dude. Hell yeah. Dude, okay, we learned something. Right. It looks wait, this is the classic implicit discovery trap. You have the right idea, but you are missing one specific directory level. Yep, that was bin. And Rust Cargo doesn't just look for any folder with a main.rs. It specifically looks inside a folder named bin to find those subdirectories. Okay, now let's try something else. Because I'm curious about examples. Which thing have I hold on, let me go into Scratch stuff. Could it be Ratatouille? Okay, so in Ratatouille we have a couple of examples. Here we have apps. Okay, each of these seems to be its own separate project. Is that what we are supposed to do with examples? Oh wait, don't do that. Yeah. Okay, a Rust analyzer is lost. Instead, if you put everything inside bin, okay, cool. Okay, that solved the problem. Now I'm wondering how examples works. Is it similar to bin? I'm confused because For example, in the Ratatouille repo, I've seen an examples folder. There are subdirectories within examples, and each of those subdirectories has, just a second, the stream that I had running seems to have frozen, and I think it's an issue on my side. Yep, it's an issue on my side because we are also dropping frames. But yeah, each of those subdirectories has example projects. Here's the thing though, each of those example projects are actual Rust projects, not just a bunch of Rust code files. Am I missing something here? I'm wondering if I'm confusing examples in workspaces versus examples in cargo. What's the other one that I'm so versus versus examples in projects. I don't know. Let's say that. Okay, you've spotted exactly where things get tricky. There are two different ways to handle examples, and the Ratatouille repo is using the more complex one because it is a workspace. Okay, the simple way, which is project level examples. This is what most small to medium crates, like your and likely your ESP32 project, use. It works exactly like the source/bin structure we just discussed. Location is under examples. Structure, you can have examples/hello or examples/whatever directory name/main. The behavior, these are cargo targets. They share the cargo toml of the main project. You run them using cargo run examples or example name. Limitation, if your example needs a specific dependency that your main project doesn't use, you have to add that dependency to your main cargo toml under dev dependencies. Okay. I feel like at a certain point, I'm going to have to dive deeper into learning everything about the cargo toml file, and also learning about the various extra cargo features like workspaces, for example. Though a lot of times I try to stay away from cargo toml because in many of the at least simpler use cases, they have developed commands that do what you would otherwise be doing in cargo toml. So then you don't have to go into your cargo toml and edit a bunch of the code there. Instead, for example, if you want to add a dependency, if you want to add, let's say, Ratatouille to your project, just as an example, I don't remember if you have to enable any features or anything, but let's say you want to add Ratatouille to your project, you can add it to the cargo toml file, but you can also do it using cargo add Ratatouille. So you can just enter that command in your terminal, and as long as you're within your project directory, it's going to add the dependency to the correct cargo toml file. And you can also additionally specify features through the command line method. So just like this, you have a couple of other sub commands that help you do stuff that you would otherwise be doing manually by editing the cargo toml file. And I kind of avoided looking into the cargo toml file initially when I was learning Rust a while back because it was just a little too much information to take in, considering that I was still learning Rust. Like I was still trying to wrap my head around Rust itself. But yeah, now I feel like I'm ready to dive deeper into this thing. I feel like now is actually the perfect time because now I'm slowly going into more of the advanced stuff in Rust. I'm no longer just a beginner. As much as I would still call myself a beginner, I feel like I'm not really a beginner at this point. I'm definitely not, really experienced in it. I'm by no means an expert in it. I'm probably never going to call myself an expert in it, but like I'm by no means really experienced in Rust, but I also don't think it's fair to call myself a beginner at this point. Though I might still be a beginner because I still don't have too much experience of working in projects in Rust. Like I still need to get that experience, which slowly I'm getting it. Anyways, so the Ratatouille way, which is workspace level examples. If you look closely at the Ratatouille repository, you'll notice that their examples are often full-blown independent cargo projects with their own cargo toml files. Yes, that is true. This also got me curious about something. I want to do something here. Let me see if I'm able to open. Am I able to copy the file? It's here. Yeah, Ratatouille. So here we have a cargo toml file. Yeah, I want to look into this. Oh, they have examples and apps under examples. Does examples have its own? No, examples is not its own. I was wondering if it's like a workspace within a workspace kind of situation, but no, it's not. Um, Even this. Okay, let's go to the bottom of apps. Yeah, this is also just directory, directory. Di I'm not sure what this directory is for. I'll look into this later. Um, this folder contains examples that are so and so, so and so, so and so. Oh, this is telling you how to run the examples. Oh, hold up. This says cargo run P, not cargo run example. Have I cloned nano here? Actually, if I did, I probably deleted it as well. Yeah, I think I deleted nano already. Never mind. Okay, I'll open up cargo toml here. Okay, so I'm not even sure what I'm looking for. So these are all the dependencies, right? Workspace.dependencies, okay? Then we have this and this. Okay, okay. How long is, okay, we're almost at the end. Um, workspace.lints.clippy, okay. So up here we have workspace members. Okay, this is not included as it doesn't compile on Windows. Oh, okay, yeah, because I'm doing this on Linux. Actually, no. How does the repo know that I'm doing this on Linux? I haven't compiled the Ratatouille repo on here. Maybe just in general they've kind of commented the thing out, but they didn't want to delete it just in case if it might be needed later on. I'm not sure. I'm not sure what's going on there. But default members, Ratatouille core. Okay, okay, and here we have examples. Okay, right. Let's see. Okay, Okay, the Ratatouille way workspace level examples. If you look closely at the Ratatouille repository, you'll notice that, yeah, each of them are often full-blown independent cargo projects with their own cargo terminal file. How this works, the workspace, the root, okay, workspace members independence. Okay, the workspace. The root cargo.toml defines a workspace. It says, hey, cargo, this isn't just one project, it's a collection of many projects. Then members. The root file lists all, by root file, I'm assuming they mean the root cargo.toml file. It lists all the subfolders, including those inside examples, as members. Okay, that's what we have going on here. Okay, all right. Then independence, because each example is its own project, it can have its own, just a second. Okay, so because each example has its own is its own project, it can have its own cargo.toml, its own dependencies, and its own source slash main. Why does Ratatouille do this? Okay, dependency management. One example might use, yeah, okay, that makes sense. Yeah, different examples might have different other dependencies that aren't necessarily part of Ratatouille itself. So that makes sense. Wait, so what's the difference between dependencies and dev dependencies? I'm curious about that. Let's go take a look at the uh, cargo toml file of one of the examples. So we have examples. I'm also kind of interested in this thing because it mentioned examples slash apps and examples slash concepts. So these two are listed as members. Here, let's take a look at Canvas. Yeah, it doesn't say dev.dependencies, it just says dependencies. Okay, all right. Real world feel. It allows users to copy paste the entire folder as a template for a new project. I never even thought about that, dude. Holy shit, I did not think about that. To be fair, up until recently, I hadn't even noticed that each of these had like separate toml files. Because when I would see a parent toml file, which I didn't even think at the time was the parent toml file, I would just be imagining it's one big project. So, just copying one component out of it might not work. Okay. Let me Google cargo run p. Okay. Cargo run. Oh, you know what? I could probably just do it here. Cargo run help or cargo help run. Yeah. Yeah, this is odd. Like, so I'm used to doing this kind of thing in order to get help. And then if there's a sub command, I'm used to doing something like this. I'm not sure if that works in this case though. Oh, it works in this case. Then why is it telling me to? Oh, this gives, okay. So this was a bad example to give, but I have seen situations where um, it'll expect you to do command, help, and then subcommand. I can't remember where I had that issue. Maybe it was with .NET because .NET also has like its own. Um, yeah, .NET also has its own like stuff. I can't remember where it was, but there was a situation where that was the case. In this case, though, cargo run help gives you the terminal help, whereas, or it gives you help that can be, just a second. It gives you help that can be printed out in the terminal, but then cargo help run gives you a man page sort of thing, like a manual kind of thing that you can read in this way. And I think it gives you much more information as well. Whereas the other one is a little more concise. So you have like all the flags being listed, and there's like little one-line statements about each of those flags. But yeah, okay, bad example to give, but I have seen situations where I had like this weird kind of thing because I'm used to putting help at the end along with those two dashes, but then in certain cases it would ask us to do it in this way. Anyways, whatever. So cargo run P might be mentioned here already, so I probably don't need to look at the man page, or maybe I do. No, P is package. Package with the target to run. All right. Okay. So that's done. Just a second. Okay. All right. Next, I would like to explore the lib part because I've never actually made a library in Rust. Like, how does that whole thing even work? So far, I've mainly been working with binary crates, and that's usually as simple as cargo run, uh, and then you get your result. Okay, in Rust, a library crate is essentially a collection of code that cannot run by itself because it lacks a main function. Instead, it defines the tools, that is functions, structs, enums, that binary crates can use. When you have source slash lib dot rs file, when you have a source slash lib dot rs file, Cargo treats your project as a library. How a library is structured. The source slash lib.rs file is the root of your library. Anything you want other people or your own main.rs to use must be marked with the keyword pub. Okay, so here's an example. So I think another thing that made this a little bit confusing for me was that I think when I was reading about, hold on, before we go into, well, there's quite a bit of information here. Because, okay, let me add that to the prompt. Um, Something that seems to be confusing for me is that back when I was new to Rust, I remember reading somewhere in the docs that you can either have a library crate or a binary crate, not both. Um, Also, could you refresh my memory um, about crates and hold on, I'm about to lose my train of thought. Wait, hold on, stick to it. Crates and something more. Packages, there you go. Crates and packages, crates, packages, and whatever a unit of compilation is. Because like they had mentioned that a crate is a unit of compilation, but like I would like to revisit that whole concept again. Okay, this is a common point of friction because Rust terminology has very specific meanings that overlap in daily conversation. Let's clear up the one or the other myth first, then dive into how libraries actually function. The binary versus library myth. You likely read that a crate is either a library or a binary. That is true. However, a package can contain, I think that's the part that I'd forgotten, that a crate is inside a package. Or maybe I never even got to that part. I don't remember. Actually, we could look at the documentation right now. Um, hold up. So I could do it here. Oh, it was being explained in, I believe, in the modules section, because that's where they were kind of they were showing us like the hierarchy, or how the entire collection is. It's like, you know, a package, and within the package you have crates. Crates can be binary or library, and then within these binary or library crates, you can have modules, and your own crate. The main function is part of the sort of root crate. Give me a second. I have multiple mice here, and I'm just accidentally clicking things here and there. Hold on. Um, what am I looking for here? Yeah, yeah. Rust modules. A module is a module is a collection of items, functions, structs, traits, impl blocks, and or even other modules. Okay, all right. Um, Control scope and privacy with modules. Okay, all right. This might be what I was looking at previously. So give me a second here. I don't think we need to be this zoomed in. No, was it here? I don't think it was here necessarily. Packages and crates. There you go. That's what I had read. Packages and crates. So this is where I had gotten that information. It said, okay, the first parts of the module system we'll cover are packages and crates. A crate is the smallest amount of code that the Rust compiler considers at any time. Even if you run Rust C rather than Cargo and pass a single source code file, as we did all the way back in Rust Program Basics, um, the compiler considers that file to be a crate. Crates can crates can contain modules, and modules may be defined in other files to get compiled with the crate, as we'll see in the coming sections. A crate can come in two forms: a binary crate and a library crate. Binary crates are programs you can compile to an executable that can run, such as so and so, so and so, so and so. Library crates don't have a main function, and they don't compile to an executable. Instead, they define functionality intended to be shared with multiple projects. For example, so and so, so and so, so and so. Okay. A package is a bundle of one or more crates that provides a set of functionality. This, I believe I just forgot this entire thing because I didn't really go into more advanced Rust things. We did read this. I do remember reading this because I'd read this on stream, in fact. Um, okay, a package contains a cargo toml file that describes how to build those crates. Cargo is actually a package that contains the binary crate for the command line tool you've been using to build your code. The cargo package also contains a library crate that the binary crate depends on. Okay, other projects can depend on the cargo library crate to use the same logic the cargo command line tool uses. That never occurred to me, actually. Okay, a package can contain as many binary crates as you'd like, but at most only one library crate. This is another thing that I wasn't able to like pinpoint what little thing I was remembering. This was also one of those things. It says a package can contain as many binary crates as you like, but at most only one library crate. Though, okay, it mentions here, oh, it's not that a crate has its own cargo toml file. A package has its own cargo toml file. And then a package can contain multiple crates, and each crate can be a binary or a library. And you can have multiple binaries, but you can only have one library. A package must contain at least one crate, whether it's library or binary. Okay, and this is where I think further on they had taken us through an example of a library. I believe. I don't remember. I think so. Maybe. Hold on. Let's see here. No, this doesn't go into. No, this doesn't go into that. Where was the library thing? Yeah, no. Okay. Okay, let's continue reading this thing from Gemini. Okay. You likely read that a crate is either a library or a binary. That is true. However, a package can contain multiple crates. The rule: a package can have 0 or 1 library crate and as many binary crates as you want. The both scenario. When you have source/lib and source/main, Cargo treats this as two separate crates bundled in one package. The library crate is the core, and the binary crate is a customer of that library. Definitions of packages, crates, and modules. Think of it like a shipping logistics system. So the package, everything is defined by. Okay, I'm going to read out the analogy. So the package is the shipping box, the crate is the product inside the shipping box, and the module is the components. So you can have multiple products inside the shipping box, and each of those products can have multiple components. Okay, so the package, um, technical definition, everything is defined by one cargo.toml. It holds your code, metadata, and dependencies. Crate, a unit of compilation. It's the smallest amount of code the compiler looks at once. Source/lib is a crate. Source/bin/app.rs is another crate. Then module, item inside the crate, which is with the mod keyword. Okay. The unit of compilation. In Rust, the compiler, rustc, doesn't compile file by file like C++. It compiles crate by crate. When you change one line in main.rs, the compiler doesn't have to recompile your lib.rs if the library hasn't changed. This makes builds faster. All right. How the library lib.rs works. When you write a library, you aren't writing an execution flow, you are defining an API. Step A, defining the library. In a library, everything is private by default. To let your binaries use something, you must mark it as pub. Okay. Then, using a library in a binary. Your binary treats your library as if it were an external dependency. like CRD or Tokyo, but uses your package name from cargo.toml. Uh, uses your package name. Okay, okay, all right. We could try that. Hold on. So in here, where am I looking? Here. Here we can create a lib.rs. Um, I like this. Depending on which, depending, wait, what did I just hit? Yeah, depending on which buffer you're currently looking at, Explorer is going to show a different area. So like right now it's showing the Ratatouille directory, which is basically where cargo.toml is. And if I change the buffer to this, then now it's showing me this some Rust project. I should rename today's stream to something else. I need to come up with a different name because today's stream ended up being more about exploring Rust project structure. I'll come up with a good name after stream because today's stream was definitely not about ESP32. It started with being about ESP32 to be fair, but yeah, we've gone into this now. It's good though because we are making a lot more progress than we did yesterday. So that's something. Um, where was I? Yeah, reading Gemini. So using a library in so and so. Okay, okay, okay. In your cargo, just wait, hold on. So here, let's do something. Um, okay, let's do it in this, and let's also open up lib. In lib, let's create a function, sum. Though if it's being accessed the same way, there might be a clash. So hold on. Right, so this takes this, and it takes this, and it returns that, and then we just do this plus that. Okay, that's done. Now in here, how would I go about doing this? So let's say use some Rust proj, some O1. That's interesting. Back up, back up. Where did I define that? Oh, it's defined there. What if, wait, so this is also a crate, isn't it? Library is a crate. Each of the binaries are also crates. What if I made this public? Would that even work? I don't know if that works. Let's see. So we don't have access to this. Though, yeah, no, how do we like go a step up? Is that like a super or something? Yeah, I should ask this question. Because like, okay, library is treated as, oh, it's because library is treated as one of the dependencies. It mentioned it here, right? Your binary treats your library as if it were an external dependency, but it uses your package name from cargo.toml. If your cargo.toml name says so and so, then it's so and so. Okay, all right, great. Why bother with the library? In your ESP32 project, ESP generate gives you a lib.rs because one, testing, two, shared logic, organize. Okay, well, now that I know about library, um, I can kind of see why it would be useful. Though I would mainly be working with um, like those individual binaries, and I need to put my main code into one of the main.rs files. Sorry, zoned out. Okay, linking binaries automatically see the library in the same package. Okay, so I have a doubt. Um, Going back to my app01, app02, and app03 project, um, let's assume I also have a lib.rs file in the wait, does this mean that, hold on, would I be able, let's try something here. What if I put a lib.rs file here? Would that cause issues? Okay, there's self, there's crate main. Oh, that's this crate. Self is also this. Okay. Let's hold on. Lib.rs. This file is not included anywhere in the module tree. Okay. Okay. Yeah. So I was wondering like how deep does that, can we like also have a lib file inside that crate? But then the thing is that that one binary, that one, that entire directory is then being treated, it's being used to compile that one binary, right? The lib in it is not going to be seen as like a separate library. And I was trying to see if it would be seen as a separate library. Okay. Right. Let's assume I also have a lib.rs file in the src directory. What was my question? Oh, I am able to define a public function in lib and then access it from app01/main. However, what if I wanted to access a public function from app02/main in app01/main? The short answer is you cannot do that directly. In Rust, a binary crate is a dead end. It's a final product designed to be executed, not a source of code for other programs. Because app01 and app02 are separate compilation units, i.e. separate crates, they don't know each other exist and cannot talk to each other at the code level. If you find yourself wanting to use a function from app02 inside app01, it's a clear signal that that function actually belongs in your library. True, true. The rules of the road for Rust projects, lib to bin, very common. The library provides the tools, the binary uses them. Bin to lib, impossible. The library is built first. It cannot see code inside the binaries that will eventually see it. Then bin to bin, impossible. Binaries are peers. They are compiled independently. How to solve this? The extraction pattern. If you have a great function in app02 and app01 needs it, you follow these steps. The starting state. This has a function, then the move. Cut the function out of so-and-so and paste it into so-and-so. Ensure it's marked as pub. Use okay, that's basically yeah, that's basically it. So your main point is that I just need to move it to lib. A pro tip for your ESP32 work. If you are writing a driver for a sensor in app02 and realize you need it in app01, move it to lib.rs immediately. It might feel like extra work now, but it makes your code much easier to maintain as your project grows. Okay, I also noticed that I cannot have a lib file in any of the app OX directories. Rust Analyzer doesn't work in them. This is exactly right. You've hit one of Cargo's most rigid opinions. In a standard Rust package, there is only one library crate allowed, and its entry point is source lib. Okay, when you put a lib.rs inside so and so, Cargo essentially says, I don't know what this is. I'm looking for a main.rs. I'm looking for a main.rs to make okay. I'm looking for a main.rs to make a binary, and anything else here is just a lonely file I'm going to ignore. Because Cargo ignores it, Rust Analyzer, which follows Cargo's lead, won't provide IntelliSense for it. How to organize inside a binary. If your app is getting huge and you want to split it into multiple files without putting the code into so-and-so, you don't use this. Oh, you use modules. Okay, so that's right. That's where modules come in. Okay, why is lib.rs special? In the Rust ecosystem, lib.rs is a public interface. It is meant to be compiled into an rlib or so file that other people or your other binaries can link against. Binaries, on the other hand, are meant to be private and self-contained. If app01 has internal logic that app02 shouldn't see, you use mod inside app01. if app01 has logic that app02 should see, it must be moved to the global lib. Okay, I feel like I don't really know the workflow for developing a library. I know how to develop a binary. What if I wanted to work on a simple calculator library? Calculator, I don't know, add, sub, mul, and div. That could then be imported into another project. What's the workflow? How do I even get started with that? Okay, developing a library is a shift in mindset. You aren't writing a program that runs. You aren't writing a program that runs. You are writing a manual and a toolbox that someone else can use. Okay. Here is the step-by-step workflow for building your calculator library. Initialize the library project inside. Okay, let's try this. So we have this, right? Let's go into Yahtzee and create a new project here. So let's say some Rust project 02. And here we're going to do cargo init lib. So that's our library. Here we want to do that and then do that. So in here we're going to have a lib file, and it already seems to have an add thing for us. Okay, right, so we've initialized the the project. Okay, then write the logic, the API. Open lib. Since there's no main function, you just define functions. Crucial step, you must use the pub keyword. If it's not pub, it's invisible to any project that imports your library. All right. Then the library workflow testing. Since you can't cargo run a library, how do you know it works? You use unit tests. This is the bread and butter of library development. At the bottom of your uh, librs, you add a test module, which that seems to be added already. Um, then your new run command is cargo test. All right, so let's do cargo test, running 0 tests, test result. Okay, that's hold on. What am I missing here? Function, it works. Okay. Okay, this compiles your library and runs every function marked with test, this is how you verify your logic, how to use it in another project. Now, let's say you have a totally separate project called My App. You want to use um, you want to use your calculator here. Option one is the local path, the development way. In your Cargo terminal, you point to the folder on your hard drive. Okay. Option B, use it in code. Wait, option A. Okay, I thought option B is going to be a different way to go about doing it. Okay, all right. So now in so and so you can use so and so. All right, documenting the polishing way. Libraries need documentation. In Rust, you use 3 slashes for doc comments. Cargo will generate a beautiful HTML website. I remember doing this. Yeah, I remember doing this. This is something I really liked about Rust is that it gives you the tools to just generate the entire docs for your library or your program or whatever that looks at so and so based on your comments and pub functions. Uh, I'm a bit confused. You mentioned that option A was to add a path to the lib in Cargo. But then in option B, you showed how to use the lib um, after having added it to Cargo. Wait, hold on. To cargo.toml. Am I missing something here? Was there supposed to be uh, another way to import the library? Okay, I see the confusion. I could have framed that more clearly. Option A and option B were two different ways to import the library. Weren't two different ways. Okay. However, your intuition is right. There are multiple ways to tell your project where a library lives. Let's clarify the different ways you can import a library into a project's cargo.toml. The three ways to import a library. Before you can write use in your code, you have to tell Cargo where the source code is. This happens in the dependencies section. So you have the local path, okay. Then you have the git repo, okay. And then you have the registry. Okay, so this is all it all comes down to this thing. Okay, all right. Um, is there a way for me to add the dependency for hold on, dependency for a local library using cargo add instead? Yes, absolutely. Cargo add is the preferred modern way to do this because it prevents syntax errors in your cargo.toml. To add a local library using the CLI, use the path flag. The command is so and so. Okay, we can try that. I'm still kind of confused about this thing, but for now, let's do cargo build. That's finished building. Now, over here, we want to do cargo add path. And then here, some Rust proj o2. All right, that's been added. And if I look at the cargo, wrong cargo toml, this one. All right, we have our dependency here. So in here, I should be able to use this, add, and then in here, we just do let a equals add. Done. Awesome, dude. Hell yeah. And then we can do cargo. Oh, wait a second. Cargo run bin app o2, I think this is. Wait, something is missing. Cargo. Yep. Oh, hold on. Let's add an extra line here. Print line. Okay. And then A. So this is also, it's supposed to be app o1. I don't know why it's, oh, okay. The line goes all the way to the end if I open this. Okay. All right. Great. Cool. Yeah. All right. So, what else was there that I had to ask? Oh, yeah. I need to go back here because, oh, hold on. Okay, so I'm curious about what exactly is being imported. This is a great question. When you import a library in Rust, you aren't actually copying and pasting the source code into your project. Instead, you're creating a linkage. What is being imported depends, no, what is being imported depends on whether you are looking at it from the compiler's perspective or the editor's perspective. The editor's perspective, when you add so-and-so to your cargo, Rust Analyzer looks at the path and reads the public API of the library. What it sees, only things marked with pub. What it gets is signatures. Okay. The result, this is why you get auto-completion and type checking in NeoVim. It's reading the metadata and public definitions. Then the compiler perspective. When you run cargo build, Rust doesn't just smash the two projects together. Compilation. Cargo first goes to the library folder and compiles lib.rs into a separate file called rlib, called an rlib. This is a specialized binary file that contains the compiled machine code plus some metadata. Linking. Then Cargo compiles your main.rs. When it sees you calling mylib.add, it looks into the rlib file to find the instructions for that function. Result, it links them together into a single final executable. Importing versus using. There's a suitable distinction between the dependency and the use statement. The dependency. This makes the library available to your project. It's like putting a book on your shelf. And the use statement, this brings the specific name into your current file scope so you don't have to type the full path every time. It's like opening the book to a specific page. Note, even if you don't write use so and so so and so, you can still use the library by typing the full path. Okay. What about the code? If your library has a private function, one without pub, it's compiled into the rlib, but your binary cannot see it or call it. The import boundary is a hard wall. This is a security and stability feature. It ensures that library authors can change their internal messy code without breaking the projects that use them. Okay, just a second. Right. So, oh yeah, I was gonna ask the question. You mentioned that it compiles the code to an rlib. Where exactly does this rlib get placed? Is it being placed somewhere in the libs project directory, or is everything, why did I write eventually? Is everything taking place within the binaries project directory? This is a great question that gets to the heart of how Cargo manages builds. The answer is everything happens within the binary projects directory. Even though your library code lives in a different folder on your hard drive, Cargo tests the binary project you are currently running, treats. Cargo treats the binary project you're currently running as a workroom. The target directory. When you run cargo build your binary project in your binary project, Cargo creates a folder named target in the project's root. This is where all the magic happens. Cargo goes to your libraries folder, reads the source code, but writes the compiled output into target. Okay. It does the same with every other dependency like CRD or ESP-HAL. Why not put them in? Yeah, you don't want to put that into the libraries because like then this in this case when other projects are referencing it, then they are going to be like overwriting that, so it's kind of pointless. Okay, Cargo avoids putting compiled files into the library's own directory for a very important reason: target compatibility. Imagine you have one library but use it in two different apps. There you go, it's exactly that, a desktop app and an ESP32 app. If a library stored its own rlib in its own folder, app A and app B would constantly be overwriting each other's files because the machine code for a PC can't work on an ESP32. By keeping the target folder inside the consumer, which is the binary, each app maintains its own specific version of the library's compiled code. The shared cache exception. If you find that compiling the same library over and over again for different projects is taking too long, there's a tool called SC cache or Cargo's build cache. However, by default, Cargo is pure. Library project folder stays clean. Binary project folder contains the target so and so so and so. What happens if I change the? Okay, all right. What happens if I change the library code? Cargo is very smart about this. It tracks it tracks the last modified timestamp of the source files in your library folder. You edit so and so, go back to your app and run cargo run. Cargo notices the library's source code is newer than the .rlib sitting in the app's target folder. It automatically recompiles the binary. Like I was about to say binary, then I stopped, and then I just said binary anyways. It automatically recompiles the library, um, updates the rlib, and then relinks your app. All right, great. Wait, what does Cargo Clean do here? A quick tip for your SSD. The target folder can get very large, hundreds of MB or even GBs for complex projects. If you want to clean it up, you can run cargo.clean inside your binary project and it'll wipe all those compiled .rlib files and binaries. Right. I had another question. Okay, and um, where exactly is Cargo looking for the source code, for the lib source code, if I installed the lib from uh, crates or Git? When you use a library from crates.io or GitHub, Cargo doesn't want to clutter your project folder, your local project folder, with thousands of source files from other people. Instead, it downloads them to a central global cache on your computer. The global Cargo home on most systems, on most systems lo- words on most systems, Linux, Mac OS, and Windows, this is located in a hidden directory in your user profile. I was about to say loser pro. Okay, in your user profile, um, which in Linux it's .cargo, and in Windows it's so and so. Okay, all right. Inside this folder, there's a directory called registry from crates.io and git from git repo for git repos. Oh, registry for crates.io and git for GitHub repos. How the structure looks. Cargo organizes these by where they came from so it can reuse them across multiple projects. Okay, from crates, it is here. From GitHub, it's here. The lifecycle of an external lib. Here's exactly what happens when you run cargo build with a new external dependency. It downloads the source code to the central folder, fingerprinting. Oh, this is another thing I needed to ask. So it seems like it's always recompiling everything. Because I've noticed that Gemini is saying that it always downloads the source code. Or rather, each time I've noticed Gemini saying this, Gemini is saying that it downloads the source code and then it compiles it. It's never saying that it's downloading a precompiled library or precompiled something, which is fair because um, the thing could be cross-platform, right? So if it's cross-platform, then just downloading the source code and then compiling it to your own compilation target is much more useful. But I have noticed that it very rarely I've seen situations where an external lib is being linked to, but rather the majority of the time what I've seen is that everything is being downloaded and then recompiled. Even like full on frameworks like CRD and Ratatouille and all of their dependencies, everything is just it's being downloaded and then recompiled. Anytime there's a change in any of those, then that thing gets recompiled. Fortunately, it's clever enough. Cargo is clever enough to not try to recompile every single thing, um, unless there's a change in every single thing. It only recompiles the specific units that have had changes in them. So the initial build might be like massive, but then the subsequent builds, they're going to be pretty small unless you're making significant changes in like all of the other dependencies as well. Okay, then fingerprinting. It records the exact version or git hash to ensure it never changes. Then compilation. Cargo reads the source from so and so, but just like your local library, it writes the compiled rlib into your local project's target folder. Reuse, if you create a second project that uses the exact same version of CRD, Cargo sees it's already in the global cache and doesn't download it again. It just recompiles it for the new project. Can you see this code in NeoVim? Yes. Did I ask that question? I was about to ask that question. Um, Can you see this code in NeoVim? Yes. Even though the code is buried in a hidden global folder, Rust Analyzer knows exactly where it is. If you are in you know what? Okay. Um, Hold up. So what we can do is, I have Yahtzee open, right? Let's open a new tab. Let's go home and let's go to, I need to be careful of what I open here because, yeah. Okay, so cargo, bin, git, registry, cache, I think, or index or source. Which one is it? Index, source. This might be it. Here, let's take a look at CRD. How many CRDs do we have? 27. Holy shit. Okay, this is what I'm looking for. Or, well, there's other versions also that I'm looking for. Oh, let's look at Toml. Yeah, there it is. Let's take a look at this, and this is pretty much the entire project. Yeah, here it is. So this is the serializer part, this is the deserializer part. Okay, all right, hell yeah. I forgot what the thing was. Yeah, okay, Control C. All right. I just realized I might have made this a little too big. The window on the right side, I might have made it a little too big. I don't think that's an issue though, because a lot of the code, it ends up being on the left side of the screen or mostly towards the middle, or maybe it might take up around 75% of the screen horizontally. So there's still like some space there that can be used. Yeah, okay. Right. If you are in your main.rs and you go to definition, usually GD or whatever. Okay, all right. Your editor will jump straight into the source code inside that directory. Warning, your editor will usually mark these files as read-only. You shouldn't edit them because changing code in the global cache would break every other Rust project on your computer that uses that library. That makes sense? Okay. Now, what was my next question going to be? Okay, yeah, I mean, then this, okay, so your, the last part of your response kind of already answered the question, but I'll ask it anyways. I've noticed, hold on. Yeah, I've noticed you saying downloads the code and compiles the code a bunch when talking about external libraries. I've also noticed that when I have a Rust project with external dependencies, there you go, dependencies, then at least the first time all the code gets downloaded and compiled. I've rarely ever seen a situation hold on, a situation where I download an already compiled, give me a second. Download an already compiled library and link that against my binary. Does this mean that pretty much always, um, at least at first, at least once, okay, that's, hold on. Um, does this mean that uh, the code for all the external dependencies gets um, gets compiled at least once per project? You've hit on one of the most defining characteristics of the Rust compiler. You are exactly right. In Rust, almost everything is compiled from source on your machine at least once per project. Unlike C or C++, where it's common to download precompiled SO or DLL, um, download a precompiled SO or DLL. The Rust ecosystem relies almost entirely on source distribution. Why does Rust do this? The at least once rule. There are three main reasons why Cargo insists on compiling your dependencies from scratch. Generic optimization. Rust uses generics everywhere. The compiler cannot fully compile a generic function until it knows what T is. If your library has a function process T, the machine code for T is different. For T I32 is different from T string. Okay, since the library author does not know. Oh, yeah. Okay. If it's a generic, then the library author doesn't know what type you're going to be giving it. That makes sense. That type can only be known at compile time when you write your code and you use a specific type. Okay. Since the library author does not know what you'll use, the compiler has to wait until it's inside your project to generate the final machine code. Okay. Then target specificity. As you've seen with the ESP30, this is what I was talking about, like different compilation targets. As you've seen with the ESP32, the target matters. A library would have to be pre-compiled for hundreds of different combinations of CPUs, operating systems, and memory models to cover everyone. Compiling from source ensures the library is perfectly tuned for your specific hardware. Then feature flags. Most Rust crates have features you can turn on or off. That is okay. That's a good point as well. Yeah. Yes, I completely forgot about features. You can choose which features you want to include. I should look into how you add support for features. Yeah, dude. Okay, yeah, most Rust crates have features you can turn on or off in cargo.toml. Example, CRD with or without derived support. If libraries were precompiled, the author would have to provide a different version. That would be a nightmare. Definitely, that would be a nightmare. So I feel like the fact that the compilation is being done, at the moment of building the binary or compiling the final binary, I feel like that's kind of powerful because that gives the developers a lot more flexibility. it gives the library authors a lot more flexibility as well, but it also gives the developers flexibility, because like the developers get to choose which features they want. They don't have to get like the entirety of the library if they don't want it, and the library authors get to not have to compile the entire thing, and they get to provide these these multiple features that people can choose. There was one more thing that I had in mind, that it kind of benefits well, the library authors. The biggest thing for them is that they don't have to compile this entire thing. It's also, if this entire thing would be compiled, it would probably also be a lot more bigger. That's another thing that I didn't take into account. It would be a lot bigger, especially if you're talking about like a crate that has, many features, something like Bevy, which is already massive. um, if you enable like all the features on it, it's going to be even bigger. Okay, the workflow, compilation and caching. While it feels like you're compiling the world the first time, it does, true. Cargo is very aggressive about not doing it a second time within that project. First build, Cargo downloads the source code to the global cache. It compiles everything into your project's target folder. This is the long build. Then subsequent builds, this is what I was talking about earlier. It doesn't like redo the build unless there's a change. If you change your main.rs, Cargo sees that the rlib files on for your dependencies in the target folder are still valid. It skips them and only compiles your code. This is why second builds are so much faster. Clean builds. If you run Cargo clean, you delete those rlib files. The next build, you will have to recompile them all over again, though it won't have to re-download them from the internet. True. Can we share compiled code between projects? By default, no. If you have two different ESP32 projects using ESP-HAL, both will have their own target folder and both will compile ESP-HAL independently. However, if this is slowing you down, there are two common solutions. Workspaces. If you put multiple apps into a single workspace, they all share one single target folder. That's useful. Okay. If they use the same version of the library, it is compiled exactly once for the entire workspace. This is the pro way to manage multiple ESP32 binaries. Then there's build cache, which is SC cache. There's a tool called SC cache, which is shared compilation cache. It stores compiled artifacts in a global folder. If project B needs a library that project A has already compiled with the exact same settings, SC cache will just hand the compiled file to project B. Then the ESP32 context. For your ESP32 work, this compile from source approach is actually a blessing. It allows the compiler to do things like link time optimization. It can look at the library code and your code. What? Oh, it can. Oh, okay, hold on. It optimizes things out as well. That's interesting. It can look at the library code and your code together and tree shake out any functions that you aren't using, which is vital for keeping your binary small enough to fit on the ESP32's limited flash memory. Okay, I was gonna have a follow up to this. Okay, I forgot what my follow up was gonna be because we've read so much here. But okay, wait. So uh, there's there's optimizations that the compiler does to even remove unused code. Also, how do I go about adding features into my own custom library? Library. Okay, Oh wow, dude. We are at like close to 2 hours. That's awesome. Hell yeah, dude. We made some good progress today. I've learned quite a bit. And I'm going to continue this learning thing. I'm glad that I even got the chance to explore library projects, library crates. There's a lot of experimentation I want to do here, and this is really useful. The lib thing, the lib.rs file in a binary project, it's really useful because it allows us to create. Oh, there was another question that I had. What if lib is complex enough that it needs to have multiple files, and I want all of that to be, you know, reusable within other binary crates within this same package. Okay, so Gemini replied, yes, the compiler is incredibly aggressive about this. In the world of systems programming, this is often called zero cost abstractions. You only pay in binary size and CPU cycles for what you actually use. Okay, I didn't know that that's what's called zero cost abstraction. The magic of tree shaking, dead code elimination. When you compile your ESP32 project, the compiler doesn't just copy your library into the final binary, it performs a reachability analysis. The analysis it starts at your main and follows every function call. If a function in your library is never called directly or indirectly by main, the compiler simply drops it. Link time optimization. This is the heavy duty version. This is the heavy duty version. Normally, the compiler optimizes one crate at a time with LTO enabled, very common in embedded Rust. The compiler looks at the entire program, your code, and all libraries as one single block. It can then inline code across crate boundaries and delete massive chunks of unused library logic. This is why you can import a huge library with 50 features, but if you only use the add function, your final bin file on the ESP32 will only grow by a few bytes. How to add features to your library. If your library is growing and you want to give users or yourself the ability to pick and choose which parts to compile, you use cargo features. Define features and so on. So open your library's cargo toml. You add a features section. Okay. And then use conditional compilation in lib. CFG feature this and this. Oh, so you decide which functions and I guess which types as well, which structs and stuff are included in a certain feature. How the consumer uses so and so. So then the consumer will have to mention those features in as well. All right. Okay. Hell yeah, dude. Awesome. Now, give me a second here. Oh God. Bad time for my internet to start acting up. Oh, okay. We are fine. We are fine. Give me a second. Hold on. All right, cool. So we are gonna go over to this person's stream. Their name is Walbury Walbury Worm. Walbur Worm. I'm not sure. I'm just gonna type the thing in. Um, I hope they don't have any settings that prevent it. Okay, yeah, we are good. Right, so that's going to be it for today's stream. Oh, I'm hoping that we are able to maintain the stream streak until New Year's at least. I want to be able to, stream for a consecutive like 10 days or something, or maybe 2 weeks or more before I eventually end up, taking a 1 day break again. Or preferably I just don't take a break, which I mean, I should take a break once in a while, but I'm okay with, streaming every day. I kind of want to. But yeah, I'm going to continue doing this research. Eventually, I'm going to get back to ESP32. I kind of needed to do this exploration to understand that project structure. And I feel like now I understand that project structure much, much better than I did before. So I'm kind of happy about that. But yeah, that's going to be it for today's stream. I hope you guys have a nice day, and I'll see you all next time. Peace.